So now let's prove that. All right, so what we want to do is we want to prove this base angle theorem.
Do we write this?
Yep, you have to write this, right? We're taking notes. So we're going to write this down. And so here is the proof. All right, so what we're going to be given, what we're going to be told, or what we're going to be given is that AB is congruent to AC. And then we're asked to prove that the base angles are congruent. Angle B is congruent to angle C. That's a C. And this is the triangle, right? This is A, this is B, this is C, and we're told that this segment AB is congruent to segment AC. Okay, now to do this, we're going to have to do a few things, right? The nice thing about a geometry proof is we know what the answer is supposed to be at the end. The hard part about it is we got to prove or show or justify why the answer is what it is. So I'm going to make my T-chart. I'm going to say statements on the left-hand column. And then my reasons on the right. And we always start with what was given to us. So what's given to us is that A, B is congruent to A, C. All right. So now I got to prove this somehow. So so this will be like step one. Step two would be, and I like to draw a little line like this across so that it's clear what my justification is justifying. So step two then would be construct line segment AD so when I do S period, T period, that's an abbreviation, so that, or such that, AD bisects angle CAB. Okay? So now what we're asked to do is we're asked to draw a line from A to D in such a way that it bisects the CAB. In other words, this little angle here and this little angle here, they're the same. Okay? And so this is just the reason this is a construction of angle bisector. So now I'm not doing the construction because we should already know how to do constructions. So, and we're sketching this out, but when we construct this with a compass and a straight edge, we're creating this line AD such that it carves this big angle into two equal angles. So now based on that, we've determined that angle CAD is congruent to BAD. Angle BAD, bad. All right, now we know this because this is the definition of an angle bisector. right? It's an angle bisector just because when we constructed it, it divided this big angle A into two separate little angles. And by that definition, by the way, when Mr. Adams writes out DEFN, that means definition. So mathematicians are kind of lazy in some sense. They don't like to write out certain words, but they have abbreviations for a lot of things. And Mr. Adams is going to start teaching those to you.
You have a lot of abbreviations.
Yeah, well, I was properly trained. So now, okay, cool. So based on that, I kind of have two triangles if you want to think about it. Right? What I mean is, all right, now I've got this triangle here. And this triangle here. Do you guys see that coming up? You see that? So by doing that angle bisector, I have two triangles there. Okay? Now, if I can prove that these two triangles are congruent, then I can prove that B and C are congruent. Does that make sense? How would I prove that these two triangles are congruent?
Would it be the side angle side theorem?
Side angle side. So now what's the second side?
The line AD.
Yeah, so line AD is congruent to itself, isn't it? So I'm going to call it DA though. So for step 4, I can say that DA, line segment DA, is congruent to line segment DA, and that's the reflexive property. Okay. And then lastly, I guess what I've just done is I've proven in step 5 that triangle ADB is congruent to triangle ADC, and that's based on the SAS, side angle side. So just to kind of recap that, what I've done is I have a yellow triangle, I have the green triangle. By the definition of a perpendicular bisector, not perpendicular, angle bisector, I created two congruent angles, and I already had two congruent sides. So now by me saying that the line segment AD, so if we look at this, the line segment AD is congruent. I have proven that this triangle is congruent to this triangle because I have a side and an angle and a side. I have a side, an angle, and a side. Now what that means is that the corresponding parts are also congruent. So this angle of the triangle has to be congruent to this angle because I've proven congruence. And so what we would say finally for step 6 is we would say angle B is congruent to angle C, and the justification for this is CPCTC. Now I'm going to write this out. This is the abbreviation, but that stands for corresponding parts of congruent triangles are congruent. Okay, so corresponding parts of congruent triangles are congruent. So a lot of times what we're going to do is we're going to have a triangle, which could be kind of divvied up into another triangle. And then what we could do from there is we can prove that the corresponding parts are congruent of congruent triangles. So for the next couple of weeks, almost every proof we do will end with CPCTC, which is the abbreviation for corresponding parts of congruent triangles are congruent. Okay? And that's the proof for the base angle theorem. Are there any questions? No? Okay, good.